my compound interest formula, but now it's to the 36th power. Do you guys know about the second answer key?
Yes.
Yeah.
If you type this in correctly the first time, hit second answer and just change the 24 to a 36.
I don't have that button.
Oh. You TI-89 user? I have no idea what to tell you.
Yeah, I do. I lied.
You hit second enter, I'm sorry. No, that's not it. Wait, second answer. No.
So now I'm going to the last.
Where do you get that one back?
Second enter.
That's what I thought. But, oh, you've already got rid of it.
Yeah.
It is the one.
There it is.
That's it.
Okay, so I got that back. If you keep getting second answer, you keep getting it back.
So
So
fast.
now let's just do that to the 36. Yeah, see how much faster that is?
Whoa. Oh, I don't know.
You forgot the 1 plus.
You balled over. What was it?
You forgot the 1 plus.
What happened in there though?
You know how fast?
It's $1.16.
What are you?
$1.16. Okay, are we doing better than last year? Are we? Hey, guys,
I don't remember.
are we doing better than the simple interest?
Yeah.
Slightly.
No.
Yeah.
We're at the same.
No, this is 3 years and we're out.
You
No,
got
we're at the same. We're at the
Yeah, we
same.
are at the same.
We're at the same. Okay.
What? Do better eventually.
You will do better over long time.
Isn't that 3 years though?
Yeah, this is 3 years, and we were at $1.16 on simple interest as well.
I thought it was $1.16 for 4 years though.
Nope, that was we're at like $1.21 by then. Your $1.22 is where we're at. Let's see where we're at with 4 years. Let's see if we get to $1.23. So put this back in and just hit 48. And what do you get?
$1.20.
No.
$1.21.
Really? What's it round to?
Really?
It doesn't even round to $1.22?
1.2057.
That should not be going down.
Oh,
That should
hi. I
definitely.
put 45, not 48. That's the problem.
Okay. Haha. Let's try that again.
$1.22.
Doesn't round to 23? Nope, it doesn't. Okay, so we're still at $1.22. Not much advantage here to compounding monthly, at least for $1. Okay. I'm going to erase this now, and we're going to go over. You guys ready for me to erase this?
Yes.
Or the easy one.
Well, yeah, the easy one. Continuous compound interest.
Don't erase it, let it be.
Nabil, you are good at this game.
Yellow submarine.
Are you that? Eli,
You're going to find yourselves in times of trouble in a minute. Okay.
Why don't you just give me some help?
We already did help.
Speaking
Did
of
help and a little help from our friends.
Two different songs.
Okay. Interest rates. Continuous compounded interest.
I think you should make a sad song.
You know, I was happier yesterday before you guys were doing this.
All right, let's come together.
Right now.
Continuous compound interest. I went over last year why this was the case. This year I will just hand it to you. Continuous compound interest. The amount in your bank account is the principal times E raised to the rate times time power. We call that PERT. A equals PERT.
Oh, yeah, I remember this.
What is E roughly?
I don't remember.
And how can you remember it?
It is two.
Andrew Jackson.
Andrew Jackson, what about him?
Oh, he was the 18th president.
Nope.
No.
He was the
He was
He was
elected
seventh
in
president.
1828.
How many terms did he serve?
2.
He served 2 terms as the 7th president beginning in 1828.
I knew there was an 18 somewhere.
There was an
in
18 in there somewhere.
What?
I got the Andrew Jackson part correct.
That's right. And E is the Andrew Jackson constant.
I have no idea what you're talking about, but okay.
I don't care. That's pretty good.
Andrew Jackson, he was the president in 1828.
Yeah.
He served 2 terms, and he was the 7th president.
And he became movement.
Okay.
You could just remember it.
2.71828. I think it actually repeats 1828 again.
Yeah, it does.
It is like pi. It is an irrational number. It will go on forever and ever without following any
Isn't there
repeating
already
pattern.
an E button on there?
Forever.
And there is an E button on your calculator, which will bring it up.
Is that why you like this number?
Because it's irrational?
No, because it's Andrew Jackson.
Oh, wait.
No, I actually like this number because in calculus you learn that E, you know how pi relates to everything with circles? If you're dealing with circles, you're dealing with trigonometry, the unit circle last year, we were always talking about pi. Remember that, how pi shows up a lot? E is the number that shows up when you're talking about anything that changes in proportion to how much you have. Which means E describes population growth.
If we're talking about E, I'm surprised we haven't talked about log.
Wait, how do they have a
We're
number?
about to, we're going to.
How
Pardon?
do we not-
How can they have one number that circles every kind of population growth?
It's because if you want to express in calculus, the idea that you have something that changes in proportion to how much of it you have, you guys remember how, like delta y over delta x was slope? You ever see that? You know how delta meant change? Well, change at any instant of time is represented by a lowercase d. So if you have a change in y over a change in x, this means change at an instant. This means change over an average. And if you have something where the change in any instant is proportionate, meaning multiplied by some number, to how much of the thing you have, the solution, this is called a differential equation. These are called differentials. When you solve this, the answer involves natural logarithms, the base of which is e. And you can prove that.
What was that number?
So anything where how fast it's changing
Mr. Bell.
is proportionate to how much you have, e is going to be part of your trying to figure out how fast it's changing, what's going on. Yeah.
What was that number you told us? It was like the most beautiful number in the universe, and it was like E times pi times negative
That's the most beautiful
1.
equation in the universe. It's e raised to the I pi plus 1 equals 0.
But
E raised to the square root of negative 1 times pi plus 1 equals 0. It's an equation that I can prove to be true. I can't prove it to you guys yet because there's some things you haven't learned. And it relates the 5 most important numbers in mathematics. At the end of AP Calculus BC, or second semester college calculus, someone who's there, I can teach them where this comes from. Yes, sir.
Well, since I don't have an E button, I'm guessing that E to the X. No, I don't.
Do e to the 1. If you have an e to the x, just hit e to the 1.
Definitely an E button.
Okay, that'll work. Compound interest, you guys good with that? You can plug in rates, times, and principles, I think.
All you're doing is plugging it in.
Yes. The rest of the homework is graphing, and it is page 206, 20 through 50 even. Okay?